What's up guys, this is Massey. Welcome to another video. In this video I want to talk about linearization. What does that mean when we are talking about linearization? Sometimes we can approximate complicated functions with simpler ones that give the accuracy we want for specific application, and they are easier to work with. So the approximately function is called linearization, and they are based on tangent line. So let's see the formula. In general, the tangent to y equals to f of x at the point x equals to a, where f is differentiable and passes through the point a and f of a, it's going to be y equals to f of a plus f prime a times x minus a. Let's see an example. It says find the linearization of f of x equals to square root of 1 plus x at x equals to 0. So based on the formula we had, we can say y equals to f of a plus f prime a times x minus a. So a is 0 in this case. If we sub it there, it's going to be f of x equals to 0 is going to be square root of 1 plus 0, which is going to be square root of 1, that is 1. And on the other hand, we need to find out the derivative of this function. F prime x is going to be 1 over 2 root 1 plus x. And f prime a, which is 0, is going to be 1 over 2 root 1 plus 0. So it's going to be 1 over 2. So that's going to be y equals to 1 plus 1 over 2 times x minus a, which is 0. So it's going to be y equals to 1 plus 1 over 2 times x. So the approximation to square root of 1 plus x is going to be 1 plus x over 2 at values of x near 0. So that's how we find out the approximation. Let's see another example. Now we need to find the linearization of f of x, the same function but at different point. Square root of 1 plus x at x equals to 3. So again, I'm going to use the same formula, y equals to f of a plus f prime a times x minus a. So f of x, when it is equals to 3, is going to be square root of 1 plus 3, which is going to be square root of 4, and that's going to be 2. And on the other hand, f prime of x equals to 3 is going to be 1 over 2 root 1 plus x, which is going to be 1 over 2 root 1 plus 3. It's going to be 1 over 2 root 4. 2 times 2 is going to be 1 over 4. So that's going to be y equals to 2 plus 1 over 4 times x minus 3, which is going to be y equals to 2 plus 1 over 4x minus 3 over 4. And when you simplify it, it's going to be, that's going to be 8 over 4 minus 3 over 4 is going to be 5 over 4 plus x over 4. So as you see here, the approximation for the same function but at different point is going to give us different approximation. If you compare it with the previous example, we had the same function but at point x equals to 0. So we got this approximation in that case. Now in this example, we need to find the linearization for the cosine function. It says f of x equals to cosine x at x equals to pi over 2. So it's going to be y equals to f of a plus f prime a times x minus a. So that's going to be cosine pi over 2 plus derivative of cosine is going to be negative sine x. So it's going to be negative sine pi over 2 x minus pi over 2. So that's going to be 0. Sine pi over 2 is 1. So negative sine pi over 2 is negative 1. So it's negative 1 times x minus pi over 2. So y will be pi over 2 minus x. So that's going to be the approximation. The slope is negative 1 and the y-intercept is pi over 2.